Okay, so section 4.2 is factoring quadratic equations. We went from graphing to quadratic equations, or the corresponding function, and now we are going to factor. So there are a couple methods of factoring. There are three methods. Will be decomposition, which you probably learned in grade 10, guess and check, which is what I'm going to use, difference of squares, that's whenever they pop up. All three of these should have been covered before. Okay, I'm going to run through all three. Actually, I'm going to run through guess and check and factoring difference of squares with you. Decomposition is a method I don't like using. If you are interested in it, take a look at this slide. This will explain each step and give you an example. I think there's too many steps here to remember. I prefer to do the guess and check method, which is basically working backwards. Okay, in the guess and check method, basically you're going to write down, this is what the factoring, you're going to write down two sets of brackets like that. Then you're going to work backwards from a solution. So basically you're writing the solution first. You're guessing. The reason it's called guess and check is because you're looking at this last number, and you're going to see what factors would be placed in each spot that would also give you 5x through addition. Okay, I'm assuming you've factored before, and I don't have to go through this with you. Okay, but this is what I like to use whenever I can. Difference of squares is when you have something like this, 4x squared minus 9y squared. Okay, two sets of variables in this particular question. But here's what you got to remember, is this is what the output will look like. Okay. Basically, it's the same expression with the difference being in the sign. Okay, but we're going to look at more complicated examples like this. But it's no big deal. We'll get to it as we see a question. So, here we go. Factor. We're going to factor all three. We'll start with A. 3x squared plus 3x minus 6. Before we get to solving quadratic equations, this is a quadratic equation. We just have to run through some methods of factoring. Here, it's always important to first check for the greatest common factor and factor it out. In this case, 3 is the greatest common factor. So we're left with the following. Okay, when you factor 3 out, then you can factor this next one by guess and check. It's a trinomial, degree 2. So the solution will have to have two sets of brackets here. And you know the first terms have to be x because it produces an x squared term. There are only two factors. There's only one possible possibility for 2, right? 2 and 1 are the only numbers that will multiply to give you 2. So in this case, 2 and 1 will have to go in. Now you just have to figure out what the sign will be. In this case, 2 will be plus, 1 will be minus, because 2 minus 1 will give you this 1x here. And that's it. That is the answer. For B, 1/2 x squared minus x minus 4. This 1/2 is ugly. I'm just going to take it out. So I'm going to factor this out. When I do that, what this actually turns this into a 2. You can work backwards here. If you were to distribute this in, 1/2 times -2 would give you -1. You can think about it that way. So this one would have to therefore be -8. Then I'm going to do guess and check once again. So you can see why guess and check is just a superior method from decomposition. If you're going to do decomposition, with quadratic equations, you might as well just use the quadratic formula, which I'll show you later on. So guess and check is fastest whenever possible. So here, xx has to be there. Factors of 8, that will make 2. What do you think that will be? Okay, that will be, we have 8 and 1. We have 4 and 2. Okay, so we have to make a decision. 4 and 2 could possibly give us 2 if this is negative and this is positive. And there you go. For C, this is a difference of squares. It's pretty obvious. So up here I'm going to write down if you had p squared minus q squared. By the way, this has to be subtraction for this difference, right? The word difference of squares. Then you're going to be left with p minus q times p plus q. So, I mean, if you have this memorized, if you have it committed to memory, then you are set. Okay, 0.7 is the square root of 0.49. And then we're going to have j, okay, minus 6k, right? I'm square rooting everything. So I just did this particular one on the left. Now to the one on the right is the exact same, except with the plus. And that's your answer. Can't be factored more than that. In general, you're going to go as far as you can. Sorry for the poor writing, but you get the idea. So now let's jump into some real... Ooh, actually, never mind. Before we jump into some real examples, let's see another way of factoring. And this time we're going to factor using a method called substitution. Take a look at this first one right here. -2, and then you have this mess. Looks quite ugly. You could just distribute this out and collect like terms, and then you're going to be left with a quadratic equation. You know it's going to be quadratic because we have n and we have a 2, so you know it's going to be n squared somewhere. Or you could simply, for part A, you could say let some variable, let's say r, equals n plus 3. That implies you're left with -2r squared plus 12r, see I'm substituting in for n plus 3, plus 4. Now that is a very, very simple equation. I can grab out -2. So this is a lovely method actually. This is a really nice method. Then I can simply do guess and check here. It's not really guess when you do a lot of them, right? It's more or less you just stare at the question and think about, well, 7 and 1, right? That's what it has to be. 7 and 1 has to be -7 and plus 1 because it produces -6. So guess and check is kind of is when you start, it's more like you guess and check, and then once you do a lot of them, it's more like, so you just write down the question, write down the answer. Difficult to explain. You'll get the idea if you do a lot of them. And that's an intermediate step, so that's not the final answer. Okay, but I circled our little intermediate answer. Now we're going to have to resubstitute for r, because remember we're actually solving for n here, right? Solving for n. Okay, or we're actually trying to factor it for n. So what we're left with is -2. R is n plus 3, so you're just going to simply put that in. N plus 3 minus 7. N plus 3 plus 1. So then you're left with, now you can collect 3. Minus 7 is -4. And then we have plus 4. Okay, that's the real factored solution. Okay, let me just erase this. Okay, not so bad. Not so bad at all. Now the next one is going to be a difference of squares. Okay, a difference of squares. You can see this because 4, you can take the square root of all this stuff, right? Remember our little p squared minus q squared equals p minus q, p plus q. Just because it's ugly doesn't mean you won't be able to do it just as easily here. So for this one, and just to remind you, this one is just like the one before. Okay, there's going to be no substitution at all here. You're just going to go right into it. And this is what it comes out to be. You're going to have some ugly square brackets. But basically, that's it right there. Now, you could simplify this, okay? It would take you quite a bit, but I'm going to simplify that just like I'm basically right here from the last question. I have to go all the way down and simplify, which means I have to do some distributing here, okay? Because this will leave me with 2x minus 4 minus 0.5y plus 2. Then we're going to have 2x minus 4 and then plus 0.5y minus 2. Okay, the complete opposite of the one before. Then my final answer will be 2x minus 0.5y minus 2. When I collect like terms, we have 2x plus 0.5y. And here's where we're going to have a slight difference. It's going to be minus 6. And that, my friends, is our solution. Very nice. I'm gonna make a goal here and improve my writing in the next slide. And there's the goal. Hopefully this makes sense so far. So the final thing that we're gonna go over, of course, and it's not this is now the easiest part, is once you wrap your head around factoring, to solve is the same thing, okay, except you have to deal with this equal sign, this equals 0, in which case you're just simply going to have 2 solutions for quadratic equations, 3 solutions for, a cubic equation, and so forth. We're going to deal with quadratics though in this class. So let's do some examples. You can take a look at the ones I worked through for you in your notes, but I'm going to do these ones with you right now. Look, 1, 2, and 3. Determine the roots of each quadratic equation. The only difference here is, first of all, you have to make a decision how you want to factor it. This is a very simple one. Guess and check is absolutely fine here, as long as you can do it. As long as you can see that this is going to be 5 and 5, and it's going to be negative, negative. This is a perfect square trinomial. Now, at this point, it just so happens that these are the same factors. But you would let both equal 0 and solve them separately. Okay, I'll show you in the next example. But for here, you're going to say x minus 5 equals 0. So x has to be 5. You can kind of see if you put 5 in here, if you put 5 in for x, it would be 5 minus 5 is 0. It makes the whole expression 0, so it satisfies it. So right there, what I just did is I actually just checked it with this intermediate step. Best, though, when you check, it's best to check from the start. Okay, that way there's no errors. So if I was to put this in, it would be 5 squared minus 10 times 5 plus 25 equals 0. The question is, does it equal 0? We get 25 minus 50 plus 25, which is definitely 0. So it definitely works. I'm not going to check each one, but that's how you check each one. Okay, you just plug them back in. X minus 16 equals 0, very easy question again. This is a difference of squares, right? Sorry. Get that off. There we go. There we go. Okay, so here we're going to make each factor equal to 0, and I'll put the word or. X plus 4 equals 0. So x equals 4 or x equals negative 4. So now you get the idea. You can check that one on your own. The last one is number 3. 3x right here, 3x squared minus 2x minus 8. This is another guess and check example. You know the first terms have to be this because 3, there's only one set of factors here. There's only one possibility there. For 8, it becomes a bit trickier. You know they have to add to give you 2 in the middle here. If you place 8 over here, okay, if you place 8 over here, then what you would end up with for the middle it'd be difficult because 3 times 8 over here would be 24. So this actually might be our first example where I will guess, and let's place 4 and 2 here. What could that give us? Then we have 3 times 2 is 6 plus 4. Ooh, that could give us 2, right? 6 plus 4 is 10, but what if it was negative 6 plus 4? Then that would give us negative 2. And that is how you do guess and check. Okay, this is all equals to 0. If you're not comfortable with that, then you can use decomposition, and eventually it won't matter because we'll be able to use the quadratic formula when in doubt. So here we're going to go with 3x plus 4 equals 0. So then when you solve this, you get x equals negative 4 over 3. This next one is x minus 2 equals 0. So x equals 2. And you can check those on your own. So that's it. That's how you solve quadratic equations by factoring. Now, you might be thinking, what if I can't factor it? What if it's actually just impossible to guess the factors? Right? For instance, what if these are decimals or fractions, some ugly set? And not to worry, we're going to come up with a formula that will answer all of these, okay? No matter what. It's a longer formula, but it's when in doubt, you're going to use it. But before we do that, I'm going to show you another technique of factoring by completing the square that's useful in many applications. So do the practice problems and then move on to the next section.